So here we go. Number 1, solve that using a graphing calculator. Okay. You all right back there? You sure now? Okay. First thing you need to do, especially again, those of you that are in Physics 12, make sure your calculator is in radians. And those of you that are in physics, make sure it's in degrees for physics. I'm going to go like this, Maria. I'm going to graph left side, cos 2x. That's a period change, by the way. It's going to be 2 cosine waves. I'm going to graph right side, negative 2 over x. If they didn't give me a domain, I usually guess negative 6 pi, positive 6 pi, because Eric, I figure I'll go 3 periods left and right. That gives me some breathing room, and then I'll zoom in. Here, they did give me a domain, so view window, they said to go between 0 and 2 pi. Okay. When in doubt, my scale is pi by 6. Y min, well, this has an amplitude of 1, so it's going to be 1 up, 1 down. I'm not quite sure what this, well, it's a reciprocal graph. And I'll go from negative 3, oh, let's try that again. Negative 3 to 3 is kind of my guess. So, Alex, that's kind of how I go about it. I can't give you a better explanation than that. Then what I do is I look at the actual graph, and if I need to zoom in or zoom out, I'll go and adjust the windows. How many answers are there? Well, there's 2 of them. Second function, calculate, intersection, first curve, second curve, guess. Go find the first one. 4 point, what did I say, 3 decimal places? 4.177. That gets you a half mark. And $5.034. No, did I say that? 5.304. Okay, half mark, half mark. For the next questions, you must show work. Okay. Solve the following algebraically. Period change. There's a 2x there. So I'm going to temporarily replace that 2x with an a, but I am going to way over here write down, I know that the period is 2 pi over 2 or pi. I'm not going to forget that, because when they want the general solution, Vlad, I'm not going to add multiples of 2 pi. I'm going to add multiples of pi. Oh, except ugly cousin, it would be pi over b for tangent or for cotangent instead of 2 pi over b. So I'm going to solve this. Sine a equals negative 1 over root 2. I'm going to say to myself, this looks like a job for the cast rule. Sine is negative there and there. Hey, this is the 1, 1, root 2 triangle, pretty sure. 1, 1, root 2 triangle, where this angle, which is pi by 4, has a reference angle, has a sine of 1 over root 2. So I have my first a value, I think, is 5 pi by 4. Is this? Ryan, going all the way around to 4 pi by 4 and 1 pi by 4. And my second a value, I think, is it'd be 8 pi by 4s all the way around to 7 pi by 4s is. Of course, that's not what I wanted to find. Ryan, if I know a, how would I get the x by itself from this little line right here, from this substitution line? How would you get the x by itself? More specific. Yeah. Same thing here. If I know a, the first x value is going to be this divided by 2, which is the same as putting an extra 2 in the bottom. I think it's going to be 5 pi by 8. My second x value is going to be this one divided by 2. It's going to be 7 pi by 8. Ah, but Eric, there could be more between 0 and 2 pi. You know what? I'm going to add the period, except, Eric, what's in the denominator right here? You know what? I'm going to add 8 pi by 8 so I can do a common denominator in my head routine, because that is still pi. There is a third x value. This plus that, 13 pi by 8, would also get me there. There is a fourth x value. This plus that, 15 pi by 8, that would also get me there. Is there a fifth x value? Well, when I add, Maria, 8 pi by 8 to that, I get 23 pi. 23 pi by 8 is bigger than 2 pi, because 16 pi by 8 is where I would stop. There's my 4 values. One way to do this would be, hey, 4 marks, 4 answers. Yeah, you know what? That's not a good way to mark. I'm going to go like this. Certainly a half mark for that, half mark for that, half mark for that, half mark for that. That gives me 2 more marks to play with. Half mark if I saw that. Half mark if I saw the period change. That gives me 1 more mark to play with. Oh, I guess I'd go a half. No, I can't give you a half mark for rewriting an equation. That's kind of pointless, Mr. Dueck. Oh, I'd probably give you a half mark for the reference angle and the half mark for the quadrants or something like that. I don't know. If you got all 4 of them, Brett, you get 2 out of 2. 4 out of 4, sorry. Mitsu, you awake? Glasses are back on? Ready to see again? Okay. Oh, give the general solution. So the general solution is going to be my first 2 principal ones. 5 pi by 8. 7 pi by 8, and for both of these I'm going to add multiples of the period, which if there was not a period change, Caitlin, would be 2 pi n, but the period is just plain old pi, or you could have written 8 pi over 8, comma, where n is an integer. 1 mark. I thought 3 was a mini curveball. Well, it says solve. Okay. I guess he wants me to factor this because it is equal to 0. Okay. How can I factor this? What's the first thing that I always look for? GCF. Hey, there's a secant in everything. Okay, I get this. Secant x bracket root 3 cosecant x plus 2 equals 0. What are my roots? Well, from here, I get secant x equals 0. And from here, I get cosecant x equals negative 2 over root 3. Ah, little alarm bell goes off here. There's a 0 here. You know what? My little rule is not going to work. I have to actually take the reciprocal or go x and y and r. So there's going to be a unit circle type of a deal. Secant. Secant goes with cosine. If secant is 0... Wait a minute, Mr. Dueck. Wait a minute. Can secant ever be 0? Let me think here. What did the secant graph look like? Well, the secant graph was the reciprocal of cosine. The secant graph was 1 high, negative 1 high, 1 high, because remember, Emily, those were invariant points. It had an asymptote right there, an asymptote right there. In fact, the secant graph looked like this. Here's my question. Will this red graph that I've drawn ever be 0 high? Will it? Justin says no. You know what? No solution. That was kind of cool. A little sneaky, Mr. Dueck, but kind of cool. Here, cosecant. Well, cosecant goes with which trig function, Trevor? So cosecant is negative where sine is negative. Oh, also again here and here, just like the previous question. But this is going to be the 1, 2, root 3 triangle. Which of these angles has a cosecant of 2 over root 3? Did I write 2 over root 3? Yeah, 2 over root 3. Did I do this wrong? I drew this triangle wrong, Ellen. I had a brain cramp. If this was April Fool's, that would have been perfect, but... Okay, let's try that again. It's going, wait a minute, something seems wrong here. Which of these has a cosecant of -2 and hypotenuse over opposite? I think this guy, Spence. 60 degrees. Oh, that's degrees. Pi by 3. Which means that's pi by 3 and that's pi by 3. My first angle is going to be 4 pi by 3. And my second angle is going to be 5 pi by 3. Ellen, am I right? Woohoo! Recovered. For 4 marks, I'll probably do something like this. 1 mark, 1 mark, hello. 1 mark for that answer, 1 mark for that answer, 1 mark for the no solution, and then I'd probably give you a half mark for that, and a half mark for, nope, I already gave you a half mark for that, Mr. Dueck. Probably get, whoop, come here. Probably give you a half mark for getting the quadrants right. Something like that. That was sneaky with the secant equals 0, no solution. By the way, what's the reciprocal of secant? What does secant go with? Cosine. What's the reciprocal of 0? Infinity, sort of. This is also saying, when is cosine infinity high? Never. Highest it gets is 1. That's the other way you can think about no solution. Number 4. Okay, let's factor this bad boy. What kind of an equation is this? It's a quadratic. How do I know? It's got a square. I think it's going to factor into 4 cos x plus 5 minus 1. Is that right? I think? Again, I have no idea how I do those. My brain goes blank and suddenly the answer pops in. Factoring by grouping or grouping. You do have to be able to factor this, however method you use. Eric still likes that joke? Okay. Eric, my friend, what can I do this? No, negative. Cosine can be negative. I got no problem with the had nothing to do with the negative. Why can't I do that? What about the 5? The negative 5. What about it? What's the highest cosine graph gets? 1. What's the lowest cosine graph gets? -1. Will cosine ever get to -5 high? Right? If you're visualizing it, Eric, it's saying this. Here's cosine. Here's -5. Will those ever cross? No solution. Again, if you just do this and leave it blank and quit, I won't give you full mark because I'll think you didn't know how to translate that. You need to either go like this, or you need to write no solution or something, letting me know, hey, Dueck, I know that there's no answer for this one. It didn't throw me off. Here, have I got a triangle with a 1 and a 4 in it, SR? Okay, going to be a calculator. I'll still use the cast rule. Cosine is positive here and here, but now to find the reference angle, that's going to be the inverse cos of 1/4. Inverse cos of 1/4. The reference angle is 1.318. Which means that angle and that angle are both 1.318. My first x value, since we're in quadrant 1 there, is 1.318. My second x value is going to be 2 pi minus 1.318, which is 4.965. One mark for the no solution, 1 mark for that, 1 mark for that. Half mark for getting the right quadrant, and a half mark for finding the reference angle. Number 5. Last one. Solve tan squared plus 6 tan plus 5 equals 0. Okay. Wrong color. I think this factors into tan x. Tan x, numbers that multiply to positive 5 and add to positive 6. I think 5 and 1. I think tan x equals -1. tan x equals -5. C, A, S, T. Tangent is negative here and here. Sandali, do I have a triangle with a 5 in it? Okay. The reference angle is going to be the inverse tangent, not of -5, of 5. Oh, can tangent get down to -5? Yeah! It's got a range of all reals. By the way, the other way you could find out, or you could check, is for here, if you tried going inverse cos of 5, you'll get an error, a domain error. So that's out of my domain. Compare that with going inverse tan of 5, and hey, you do get an answer. Your calculator knows. 1.373. My reference angle is 1.373, which means that angle and that angle are 1.373. It's going to be pi minus 1.373. 1.769. And it's going to be, you know what? The next answer is going to be pi further along, because these guys are split by exactly half a circle. So I cheated. I just added pi. Is it 4.910? Yeah? People nodding? Looking vaguely blank? Here, do I have a triangle with a 1 and another, because this is 1 over 1. Do I have a triangle with a 1 and a 1 in it? I can do this one as an exact value. Turns out this one is my 1, 1 root 2 triangle. So once again, let's go cast rule. C, A, S, T. Again, tangent is negative there and there. This is the 1, 1 root 2, where this angle right here is pi by 4. So that angle right there and that angle right there are pi by 4. So my third x value is going to be 3 pi by 4. And my fourth x value is going to be 7 pi by 4. You know, here, with 4 marks and 4 angles, I'll go 1 mark, 1 mark, 1 mark, 1 mark. Then they want the general solution. Okay. Those two angles plus pi gives you all your solutions, because tangent is a period of pi. Jimmy, I didn't need to write this one here. You could have, it's not wrong. But if I wrote that, if you add pi to this one, it gives you that one. It's redundant. So you could have an x4, 7 pi by 4 plus multiples of pi. And you could have a 4.910 plus multiples of pi. But if you add pi to that, you get that guy. So it's kind of redundant. I wouldn't take marks off. Yeah. Yo. What did you get? Oh, here? The second angle. I'm sorry. The second. Here, no, because I said give your answers to 3 decimal places if necessary, which means I was accepting that. If I said as an exact value, I'd take a half mark off. I would like to think, Brett, that you might notice tangent of 1 and -1. That is a special triangle worth remembering. It's 45 degrees. Or negative 45 degrees. Pi by 4 and negative pi by 4. So I'll take it. Brett, I wouldn't have on this one where I said give us exact solution. There's the difference. Give yourself a score, please, out of 19. This one I am going to count. Put your name on it. So we've been looking at the weird and wonderful world of identities. And I gave you a few to try here. If you can open up, please, to page 346 in your book. 346 in your book. And I gave out that great big identities review sheet. That's the one that looked like this puppy right here. So anybody does not have the identities review sheet, now is your chance to ask. So I will start out by saying, either from the identities review or from page 346, are there any Excuse me. Are there any you would like me to go over? I'll do a couple. Okay, no problem. Then we're going to add a couple of more identities to your repertoire. We're going to skip lesson 7. We're going to do lesson 7 actually on Wednesday. We're going to do lesson 8 today. So if you can turn, please, in your book to page 360. Page 360, the same number of degrees in a circle. Page 360. Lesson 8. What we're going to look at today, Trevor, are what are called the double angle identities. The double angle identities are what they sound like. It's where you have, instead of just a theta, you got a 2 in front of it inside the trig function. And what we're going to ask ourselves, Eric, is very simple. Is this statement here true or false? Is doubling the angle and then finding the sine the same as finding the sine first and then doubling your answer? And it says, determine whether or not the statement can be verified using theta equals pi by 6. Okay, get your calculators out. Make sure they're in radians. And here's what we're asking. If I go the sine of 2 times pi by 6, double the angle, Trevor, and then find the sine, because bad math. Do I get the same answer as if I go 2 times sine pi by 6? Does where the 2 is matter? You get the same answer? Sabina? No. No. In fact, very different answers. Okay. Turns out, you can't just pull a 2 out of a sine. A 2 theta, we have to deal with it if it's inside the sine. Now, we've already looked at how to deal with it if I gave it to you as an equation to solve. We called that a period change equation, Maria. We replaced it with an A temporarily, and we were able to solve it. Now we're going to ask, what if it's inside an identity? So, that statement is false. Okay. Turns out, we're going to skip warm-up number 2. It turns out the sine of 2 theta is actually that. And I'll prove it to you. So here is the sine of 2 times pi by 6. There's the sine of 2 theta. That gave us that. If I go 2 times the sine of pi by 6 times the cosine of pi by 6, lo and behold, same answer. These two are interchangeable, and there is an easy proof, but the easy proof depends on lesson 7, which I've skipped, so I'll show you the easy proof in a couple of days. Oh, and just as it turns out, the cosine of 2 theta is cos squared minus sine squared. Both of these are on your formula sheet. You want to get out your formula sheet, please? Or at least have one person at your table have your formula sheet out so you can glance at it, look at it. Maybe move it to the center, Mitsu. Okay. If you don't have one, get close so you can look at someone. Yes, take an initiative, make an effort, move. Got one there? Got one there? Yep. Take a look at it. Find where it says sine 2 theta equals 2 sine theta cos theta. Is it, Ryan, about halfway down to the right? Yes? See it? Find it? Okay, you have to know where these are, so this is me training your eyes. Now, just to the left of it is cosine of 2 theta. And it says cos 2 theta equals cos squared minus sine squared. But then, Trevor, do you notice it actually has 2 more expressions for cosine of 2 theta. There's 3 possibilities. See them? Now, they are all legitimate. But they're easy to generate, by the way, because sine squared equals 1 minus cos squared. That's from sine squared plus cos squared equals 1. And because cos squared equals 1 minus sine squared, that's also from sine squared plus cos squared equals 1. If you stick that in right there, you get this guy. If you stick that in right there, you get that guy. So for sine 2 theta, there's only one possible substitution. For cosine of 2 theta, there are 3 possibilities. Which one's correct, Mr. Dueck? They're all correct, but if you do a bit of math in your head, often you'll find one of these 3 will save you a line or 2. For example, if they give me an identity, Emily, and in the original identity there's a +1, I might stick in this one because hopefully the +1 and the -1 will cancel. See it? Or if there's a -1, I might try that one. Let's use them. Turn the page. So I guess it's page 359. Now it's page 360. Example 1 says use an addition identity to prove the double angle identity sine 2a equals 2 sine a cos a. That's actually lesson 7 that I skipped, addition identities. So we're going to go to example 2. It says prove this. A says describe how to use a graphing calculator to verify it. Well, that wouldn't be that tough. I would graph this as left side, graph this as right side, and Joel, if when I hit graph only one graph appeared, I'd know they were both the same graph. We're not going to prove things that way. Instead, we're going to do B. So A, B, we're going to prove this. And now, on our formula sheet, where we also have the Pythagorean ones on the top row, we can all now also use this one. What is the sine of 2x? Brett, read it to me right from my formula sheet, please, Mr. Redeman. And I think I'm done on the right-hand side. The left-hand side, can I cancel out a tangent? Can I cancel? What question do I really need to ask myself? Have I factored? Okay, I can't. But this denominator here, do I have 1 plus tan squared somewhere on that sheet? I can't remember. Top row somewhere? Is it there? Is it there? Is it there? Emily, what is 1 plus tan squared? I can't hear you. Secant squared? Oh, so you're saying that this is... Okay. Oh, the tan on the top isn't squared. That's good, because I was doing the math in my head and saying, hey, wait a minute. I'm in a slump, an April Fool's slump. Okay, so, now what? Suggestions? Rewrite everything in terms of sine and cos? Sure. So I would go to... tan x is sine over cos, so 2 tan x would be 2 sine x over cos x, all over secant squared. What's that? As Isabel does a nice big yawn. Sure, what's secant? Did you say 1 over cos squared? Nod your head. Yes? Now, Isabel, this is a complex fraction. It's 4 levels over 4 levels, but this is the ones we already know how to do because this is 1 fraction over 1 fraction, not several over several. I don't need to do that whole trick of multiplying the top and bottom by the common denominator. I can fall back on, hey, how do I divide by a fraction? How do I divide by a fraction, Justin? Yeah, I can just go like this. Hey, Mr. Dueck, this is going to be 2 sine x over cos x times cos squared x over 1. Oh, Brianna, how many cosines on top? How many on the bottom? Can I cancel? This is factored because it's all multiplying. And I end up with 2 sine x cos x. Beauty. Let's try one with a cos 2 theta, like example 2 on page 362. So I'll do my little line. Here's my little t-table. Prove that. Cos 2 theta is a bit trickier. See, Eric, whenever in identity I see a sine 2 theta, that's 2 sine cos. Cos 2 theta, I got 3 choices. I'm either going to replace this with cos squared minus sine squared, or I'm going to replace it with the one with the cos squared in it, or the one with a 2 sine squared. I don't know which one yet. So I'm going to hold off for 1 second. I know I'm going to replace this. I'm going to work on the left-hand side a bit first. Any suggestions? What can I try on the left-hand side? Can I cancel out the tan squareds? No, these are the ones where it's really tempting. Spencer, oh, hey, that's just 1. No. So anything I can do on the left-hand side? What do you think? Replace the 1 plus tan squared with secant squared? Sure, why not? Okay. Now what? Gotta try something. There's no way I'm leaving this blank. Gotta be stubborn, gotta be clever. Yeah, let's try rewriting everything in terms of sine. I have no idea where this one's going, by the way. Let's find out. So this is going to be 1 plus tan squared is sine squared over cos squared. Spencer, did I just say over? I did? Let's go make the 1 a fraction too. I don't want some fractions and some not. Over 1 over cos squared. Why did I change the plus sign to a minus sign, Mr. Dueck? Now, Isabel, this is also a 4-level fraction, but can you see it's not 1 fraction over 1 fraction? How do I divide by a fraction? Put the multiply. It's 2 fractions over 1 fraction. This is where we're going to use that trick that I showed you. We're going to look at each mini fraction. What's the common denominator of each mini fraction? Cos squared. I'm going to multiply the top and the bottom by cos squared. I'm going to multiply by cos squared over cos squared, but I'm going to put an over 1 and over 1 so I can clearly see where my 4 levels are. Here, I'll get a cos squared left behind. A minus sign, not a plus sign, Mr. Dueck. A minus sign drops down. Here, Joel, what'll cancel? And I'll have what left behind? Sine squared. Ooh, I like the bottom. Joel, what's going to cancel here? And what's going to be left behind? Do I need to write an over 1, or can I just... Oh, okay. I get cos squared. Oh, hey! I got cos squared minus sine squared. Which of the 3 double angle identities for cosine would be the cleverest one to substitute right over here to be done? The cos squared minus sine squared one. That's why I said do a bit of math and see where you end up. Okay. Weird questions. Turn back, if you would, please, to page 360. Example 3 I'm going to write MC next to there. That's your hint that on the test these will be multiple choice. Vlad, can you read A to me, please? Out loud. Nice big voice. Did you hear him, Trevor? Read it again. That's not what I hear. Here's what I hear. 2 sine something cos something. Here's what I hear in my head when you read that. I heard 2 sine theta cos theta. Except instead of a theta, what do I have in what you read me? 4x. Not a 4. 4x. Yes? Okay. What's 2 sine theta cos theta the same as according to your formula sheet? Don't write this down yet. Now that is true if I go from the blue writing to the blue writing. But Vlad, what did you tell me we had instead of a theta sitting there? No. What do I have instead of a theta sitting here? Read to me the whole thing. This is why I barked at you 30 seconds ago. You said 4. I said, no, it's not a 4. You said, X. No, it's not an X. What do I have sitting there instead of a theta? A 4X. What do I have sitting here instead of a theta then? By the way, what is 2 times 4X? So 2 sine 4x cos 4x, that's the same as sine 8x. In other words, now, Brett, we can start to build new double angle identities by using the 2 that are on our sheet. Brianna, can you read B to me, please? That's not what I see. You know what I see? I see cos squared theta minus sine squared theta. Okay, what is cos squared theta minus sine squared theta according to my formula sheet? Okay, so this is the same as the cosine of 2... Wait, Brianne, what did I have sitting here instead of a theta in my original question? What did I have sitting right where the theta was? Ah, she figured it out in a hurry. Say that again. So, what is the cosine of 2 times a half a? Just plain old? Turns out that cos squared half a minus sine squared half a, that's the same as cos a. The trickiest one is C. Eric, can you read C to me, please? Read that loud. He figured it out. He said, I see sine theta cos theta. Do you have a sine theta cos theta on your formula sheet? Well, not quite. You have a 2 sine theta cos theta on your formula sheet, yes? See it there, Maria? Put pencils down. True? Yes? That's right from your formula sheet, yes? How can I get rid of this? Are you telling me that's also true? Oh, and does that now match that? Oh, pick your pencils up, please. You can write that up there down if you want to, but I'm pretty sure this works out to a half sine of 2. Hey, Eric, what did you tell me was there instead of a theta? What is 2 times 5 over 2? Well, 2 times 5 is 10 over 2 is 5. Or you can say, how many 2's on top? 1. How many 2's on the bottom? 1. 2's cancel. You know what? This whole thing works out to a half sine 5x. So this is a way that we can take, Tyler, those double angle identities, the sine one and the 3 cosine ones, and we can build more. How do you recognize them? Tyler, can you read to me the first cosine double angle identity? Cosine 2 theta equals what? What does it say on your formula sheet? Okay, if I see a cos squared minus sine squared, I go running off to there. Can you read me the next one? If I see a number if I see a cos squared minus a number, I go running off to there. Read me the next one. If I see a number minus a sine squared, especially if the numbers are even, like 2's and 1, I go running off to there. Oh, and if I ever see a sine cos, I go running off to sine 2 theta. See if I can make it work. The last thing we can do is, no, I think we're going to skip that, Mr. Dueck. Let me see. Yeah, nah. Nah. Sure. So, homework. Page 364. Number 5. Number 6. Number 7. And on this identities review sheet, remember last day I said all the ones with a 2 theta you couldn't do? But now you can! Okay. We're about 4 lessons from being done. We have one more type of identity to look at, sum and difference identities. Then we're going to spend a couple of days looking at trig word problems. Remember for logarithms we learned how to do like half-life and population questions. We're going to look at some trig applications, and they're really cool. And we're done. Your test is probably going to be in about 2.5 to 3 weeks. Okay? Ish. So the remainder of class, try the questions from the workbook and then start whittling away at this great big trig identity.